Hey, how's it going? Leetcode 2033, minimum operations to make a univalue grid. You're given a 2D integer grid of size m by n and an integer x. In one operation, you can add x or subtract x from any element in the grid. A univalue grid is a grid where all the elements of it are equal. Return the minimum number of operations to make the grid univalue. If it's not possible, return -1. All right. Well, first, let's get the values out of the grid. It doesn't seem to matter where they are, so we'll say items equals list of chain dot from iterable x, and then let's sort that. Sorted. All right. And then we will see what we got. Items. Return -1. Okay. Now first, let's see if it's possible. Int is not iterable. Oh, that was a little silly. Okay, so this should get all of our values out of the grid. So we have 2, 4, 6, 8. All right. Now we want to look at every value in the grid and make sure that it is a multiple of x away. So we will say for I in items, if I minus items 0 mod x does not equal 0, then return -1, because we know it's going to be impossible. Make sure that x isn't 0. No, it's never 0. So, okay. So we just need to figure out where we want to join it. Okay. So we will say left equals 0, right equals sum of items minus item 0, and our index is 0. So yeah. So then count left equals 0. I don't know if that matters. Count right equals length of items minus what? Well, -1. Okay, yeah. So while I is lesser than length items, we'll just check every position, I guess. And then we will say max equal, or let's not spell it out, just m equals, I don't know, 10 to the 5th squared, I don't know, just some really big number. 10 to the 5th squared is 10 to the 10th, isn't it? Whatever. Just as long as infinity, that's what I want. Okay. And then okay, so we're going to have things on the left are going to be smaller. So we will have to add to those in order to get to a value. We do not need a count left and count right, because it doesn't matter where we subtract them from. It just needs to add or subtract to the value that we need. So are we sure? Are we sure we don't need a count left? Oh, we do. We do, because we need to know. Okay, got it. Sorry. All right, so down here we will say I plus equals 1. This is where we advance. And count left plus, nope, this has to go above. Count left plus equals items of I, and left plus equals items of I. Count left plus equals 1. Count right minus equals 1, and right minus equals items of I. Okay. Okay. So let's figure this out. Expected left equals, let's just say n equals items of I, equals count left times n, and then expected right equals count right times n. So we're going to bring everything on the left and on the right to n, right? And then the diff is going to be the absolute value. Well, we know that expected left is less. Yeah, we have to bring this one up. So expected left would have to be, here we can check it. Assert expected left is lesser than, no, is greater than or equal to actual left. And assert expected right is less than or equal to actual right. And then m equals min of m, comma, okay, this one is bigger. So expected left minus left plus expected right. Right is bigger, so whole thing divided by x. I feel like I made that more complicated than it needed to be. Hopefully I didn't make a clerical error. Okay, return m. Name item is not defined. .0. That is not ideal. Okay, so however, that is not the right value even if it's the wrong type. 5, how odd. Okay. Am I going to have to visualize this? All right. Print items 0 to I, and then n, and then items what? Items I plus 1. Okay, some value here is incorrect, so we gotta figure out what it is. Yeah. We're gonna say expected left, expected right, Why couldn't you have just worked? Let's see what it does. Okay. So 2, 4, 6, 8. Yeah. So left and expected left are both 0. Expected right is 6. So 2, 4, 6. That is correct. And then the actual right is 14, 18. That is correct. So the difference here is 12. Divided by x, which is 2. So that gives you a 6, right? Yeah. So 2, 4. All right. So yes, we were expecting 4 here, and we were expecting 16 here. The difference of 8 is the difference of 2, so that gives us 5, right? Now the next one. 2 to 4. So we're expecting a 12. And we are whoa. That isn't right. That is not a 12. Was this one right? No. Look at that. Okay. Right minus equals items I. Was it even right in the first place? 10, 18. Yes, that was correct. And then this is 14, but it says that it's 16. It's like it didn't subtract the value. That is, it's right here. Do we set right somewhere else? Okay, oh, I mean, clearly this value is wrong. Right minus equals 2. Right? Print right before right, and then I, and then items I. What is going on? Is it like some stupid mistake that I've just made? Yeah. So I think the technique is valid. It's just okay. So right, index 0, right after. Now it's updated. No, look at that. Oh. Yep. No, that makes perfect sense. Okay. If I equals length of items, then break. And that should give the right answer now. Okay, yeah, I was just subtracting the wrong value. Okay, let's get rid of all of these. We don't need that, or that, or that, or that, or that. All right, fun. Okay, not the best complexity here. Let's see how other people did it. Best solution using binary search. Okay, so count one. Oh, look, using infinity here. Float, huh? Not integer? Okay. Yeah, I just used a chain from iterable, iterable, but he's basically doing the same thing that I did so far. I just did it here in one line. So my items is his ARR. And then, oh, look at that. He starts off XOR rem. Remainder. ARR doesn't equal rem. Now this confuses me here. Oh, no, that does make sense. That makes sense. I mean, that's clearly not how I would have done it, but so far our logic is basically identical. Okay, I did a linear search while he did this binary search, but let's see what his algorithm is. Well, okay. I guess logically, if you know that some midpoint in the middle of an array is bigger on one side than the other, then pushing it further in that direction isn't going to improve the complexity. So okay, no. I mean, we could adapt this solution here. It's this is what you're balancing against. The right and expected right, left and expected left. I should have selected the one that I said instead of backwards, but you get the idea. Yeah, but how does he generate the sums? Does he like do it like an accumulate or something? There's no accumulate here. Is he regenerating it every time? Where is he making the sum? Left, right, closest. He isn't keeping the sums. Interesting. Well, I guess I got a lot of learning to do. But it's late. I don't care right now. See ya.